Alright, so let's have a look at a trigonometry 2D and 3D problem. Alright, so without wasting any further time, let's just read the instructions and then please take as many notes as you can because I'm going to be explaining as I go along with the question. Now, points B, C, and E lie in the same horizontal plane. ABCD is a rectangular piece of board. CDE is a triangular piece of board having a right angle at C. Each piece of board is placed perpendicular to the horizontal plane and joined along DC as shown in the diagram. The angle of elevation from E to D is x, BEC is 2x, and EBC is 30 degrees. Alright, now the first question here, it says, show that DC is equal to BC over 4 cos squared x. Alright, now how do you do that? How do you show that DC is BC over 4 cos squared x? Alright, now the easy way to do this, it is to always make sure that number one, actually before we even get into that, number one, we look into the sides that are given B, right? The first thing here that I see is we are given DC. Okay, so I'm just going to write it here, DC. Okay, now the first question that you must ask when given a side is which triangle does this side belong to, right? Now in this case here, we can see that this side belongs to triangle, I can say CDE. So triangle CDE. Now notice that I didn't say which side, just any shape it belongs to. I asked which triangle it belongs to because this is a trigonometry. So in trigonometry we deal with triangles. So we don't deal with rectangles, circles, and all of that, right? We always make sure that we spend more time dealing with triangles, right? Okay. So now in this case, for example, we have CDE. Now that I have CDE, the second question that I need to ask myself is, what type of a triangle is that, right? Now, CDE is a right angle triangle because it has 90. Now, because of that, right, because if it's a right angle triangle, it means I need to think of Pythagoras, right, and SOHCAHTOA, all right? Now, why am I thinking about these? Because these are the ones that I'm going to be using to calculate either an angle or a side, right? And then, of course, if I want to calculate an area, I need to think of half times base times perpendicular height, right? Okay. Now, what's the second side that we have here? The second side that we have in this question is BC. Now, you see I'm breaking it down because I want you to understand what is happening here. Okay. Now, it's BC. Now, BC, of course, I'm going to ask the same question. Which triangle does it belong to? Of course, in this case here, it belongs to triangle BCE. Okay. Now, what type of a triangle is this? This is a non-right angle triangle because all the angles here are not equal to 90. So if that is the case, what does this mean? So it means if we want to calculate the side of an odd angle, I need to think of a sine rule and a cosine rule. So I'll just say plus cosine rule. All right. Okay. Now later I'm going to be explaining how do you know which one to use. But then not only that, when you talk about the area, we need to think of an area rule. But we are going to discuss how do you know which one to use and which one not to use. All right. Now looking at these two triangles now, triangle CTE and BCE, because we have this square here, we are going to completely ignore this square. And then now what we're going to focus on, we want to ask ourselves, this triangle, which sides do they have in common? Now in this case, it means now they have this side in common, right? Because first of all is these triangles are not the same triangles, so which means now the only thing that can help us bring two sides that are not from the same triangle into the same thing is by finding what they have in common. In this case, they have CE in common, so it means now what I need to do here is I need to calculate what is the value of DC using CE and what is the value of BC using CE, right? Okay, so now how do I do that? So now to do that, I'm gonna go straight into answering the question. Now here I can see that X is my reference angle, right? So which means DC is my opposite and CE is my adjacent. So if I want to combine DC and CE, what I'm going to do is I'm going to use 10x, right? 10x. Why? Because 10 is opposite over adjacent. So 10 of an angle x is going to be equals to opposite DC over adjacent, which is CE, right? So you see with this one, I use that one because why? Because it's a right angle triangle. Okay, so let me just fix my E here. All right. Okay, so now I know how to find DC, right? How do I find it? I'm going to take the CE and cross multiply there. So when I do that, this becomes CE 10x equals to DC. All right, isn't that easy? Very easy. Okay, so I have my DC. It is CE 10x. All right, now to make this easy, what I'm going to do is I'm going to divide this space right here, and then I'm going to talk about the other side here, which is BC, right? Okay, now let's have a look at BC. BC is a non-right angle triangle, right? So which means now here, to find or to calculate BC, I might either use sine rule or cosine rule, right? Now, how do I know when to use a sine rule and how do I know when to use a cosine rule? Now, speaking of a cosine rule, how it works is that you need to have two sides, or you need to know two sides and an included angle. Now, in this case, we know what is CE because we can calculate it using this, but we don't know any other side after that, right? So it means for us, we can't have this information using a sine rule, right? But now with the cosine rule, because the cosine rule, it says there must be two sides, for example, and an included angle, right, in order for it to work. Well, not only that, there must be three sides, right? And it's fine if there's no angle, that will work, right? But then in this case, we don't have that, right? So which means now the next thing that I need to think of, it is a sine rule, right? But then now with the sine rule, how does it work? The sine rule states that there must be a side, in order for it to work, there must be a side and an angle facing that side, right? Which is in this case, we do have BC, the one that we want to calculate, and we do also have an angle facing BC, which is 2x, right? And then remember, we're still talking about the angle that is common. So which means we do technically have CE, right? And then not only that, CE also has an angle facing it, right? Now, because of that, it means for this case, we can then use a sine rule. Now, how do we use the sine rule? Remember, we want to calculate what here? We want to look for BC, or want to see if we can calculate BC and then have CE there being a common thing. Now, which means now in this case, we can say BC over sine 2x is equal to CE over sine 30. Now, as you can see here, we have found BC and we have also found DC. And not only that, they both have CE being a common thing. Now, if they have CE as a common thing, what does then that mean? So that means now here, I can solve CE in this side because I want DC after all. So I can't change this because it already has DC as a subject of the formula. But I can change this one and solve for CE and take whatever that I get there and substitute it into this equation and then solve afterwards, right? Now, how do I do this? Basically, what I'm going to do is I'm going to take this sine 30 and multiply this side, right? So let's go ahead and do that. So when we do that, this is going to be BC sine 30 over sine 2x. Now, this will leave me as CE. Now, if I want to simplify CE further, you can see that this is sine 30 when you press on a calculator. It gives you 1 over 2. So which means now I'm going to have BC multiplied by 1 over 2, right? And then over, now for this one, I can see that this is 2 sine x times cos x because it's a double angle, right? Now because of that, now to simplify this also furthermore, I can then say this is going to be BC over 2 divided by 2 sine x times cos x, right? Now, if you know how to simplify this, it's basically going to be over 1, and then you're just going to make it BC over 2, change the sign into multiply, and then just swap around these fraction that comes after, right? And then BC times 1 will be BC, and then 2 times 2, it will be 4 sine x times cos x. Now remember, this is the value for, or this is an expression for CE. Okay, now how do I then solve for DC? So now, just not to waste space, I'll just take this and put it here and continue with my work here. So then say therefore DC is going to be equals to, I know the value for CE, right? I know here that CE, it is BC, so multiply this, so it's BC over 4 sine x times cos x. Let me just fix this, put it in the middle there. Now this is times 10x, right? Now what is 10x? If you remember, 10x, it is sine x over cos x. Now here I have 4 sine x times cos x. Now when I multiply everything out here, it gives me BC sine x over, now I have 4 sine x. Now cos x times cos x, it gives me cos squared x. Then this cancels with that, and then just from that you can see now that the value for DC, it will then be BC over 4 cos squared x, and that is basically how we prove that DC is equals to BC over 4 cos squared x. All right, so that is how we find the first one. Now let's go ahead and read the second one. Now the second one here, it says here now that if we know that x is equals to 30 degrees, now we must show that the area of ABCD is 3AB squared. Okay, now how do we do that? Okay, now we know that x is equal to 30 degrees, all right? So if x is equal to 30 degrees, what does that mean? So basically, x is 30 degrees. Basically means now here, I can say now, I'm just gonna explain it longer so that you can see what is happening. So that means that DC, right, is equals to BC over 4, and then I remember here we have cos squared x, so cos squared x is more like having cos x times cos x. All right, so now I'm expanding it like that because I want to understand, okay, that if x is 30, what would have been my DC, right? So this would have been then 4 cos 30 times cos 30. All right, so now here I want to understand now what is the value for cos 30. So cos 30, it is square root 3 over 2 times square root 3 over 2. Remember, this is still DC. So now square root 3 times square root 3 gives me 3. 2 times 2, it gives me 4. And then I have that 4 there. So it means now I have this as BC over 4 times square root 3 times square root 3 is going to be 3 over 2 times 2 is going to be 4. So this will cancel with that. And then of course from there, DC will then be BC over 3. Right, so what does this mean? So this means now here with this, I can then say that BC, it is 3DC, right? Now I'm not solving this question here. I'm just trying to understand that what happens if x is 30? What happens to what we got earlier on there? All right, and then this is what we see. Actually, we see that BC can be 3DC. All right, now I'm going to go to the question. The question, it said we must show that the area, it is 3AB squared. Okay, so now to do that, I'm going to say now the area of ABC, we know that the area of ABC is always length times breadth, right? Now in this case, my length here, it is BC, and then my breadth here, it is DC, because those are the sides that I have. I have this side and I have that side. All right, now what is the value for BC? Here's the value for BC, right? It is 3DC. Now DC is just DC, then this becomes 3DC squared. But then now, wait a second, remember, we were told earlier that this was a rectangular piece, right? A rectangular piece, it means that this side is the same as this side, and that side is the same as that side, right? So now, since now ABCD is a rectangle, therefore it means that AB is the same as DC. Therefore, the area of ABCD, because of it was 3DC squared, now we're going to change that into 3AB squared, and that is how we prove that the area of ABCD is 3AB squared. And that's it for this video. If you like the video, please make sure that you share with your friend. Also, if there's anything that you would like to leave in this video, drop it on a comment. Please don't forget to subscribe. And for all of that and more, I will basically see you on to the next video. Cheers.